Hello everyone. I hope आप लोग मजे में हो and you people are solving lots of questions. Practice करना बहुत जरूरी है in physics to get better. So let's practice one more question and this is very beautiful question. We will get to learn a lot of concepts out of it. So let us start. First, let us understand the question. So there is a disk spinning and it has a hole at its center. You can locate this hole. ठीक है? The surface of disk is horizontal. This is a horizontal surface. So if it is going in a circle, it is carving horizontal circle. ठीक है? And there is a block of mass 1 kg kept here. It has mass of 1 kg. Done it. And what else are given? Block A is tied to a light inextensible string. So this is an ideal string, massless, inextensible, because we're not talking about its mass. So we will say it is massless. So tension throughout the string will remain constant. Done hai? Now what is happening? We are letting we are letting this string pass through this hole such that it is hanging vertically like this. And then from another end, again, one more mass is attached, that is block B, right? And it has a mass of 2 kg. Done. It is said that coefficient of friction between A and this surface is 0.5. So here coefficient of friction is 0.5. Done. It was observed that disk is spinning with block A remaining at rest relative to the disk. So if you are standing at disk and observing this block A, you will find that it is at rest. So there is no relative motion between A and the disk. It means if A is going in a circle with angular velocity omega, this A is also going in circle with angular velocity omega. Both will share same velocity, then only relative thing is zero. And that is why when you are standing on the disk and seeing block A, you will find it at rest. And if you are standing on ground and seeing the block, you will find both disk and block going in the horizontal circle with same angular velocity omega. Okay? Now what is thing? Block B is also found stationary. So B is also at rest. ये इंटरेस्टिंग है क्योंकि अगर बी पे फोर्स देखो अपवर्ड तो ओनली टेंशन टेंशन ऑलवेज एक्ट्स अवे फ्रॉम द बॉडी सो अवे फ्रॉम बी एंड mg विल एक्ट डाउनवर्ड एंड सिंस दिस इज इन इक्विलिब्रियम आप क्या बोलोगे आप बोलोगे T इक्वल टू 2g so that is equal to 20 Newton. And if you talk about friction force that might act on this body A, done है, that we will explore later what are the forces acting and how it will act. But for now, let's calculate F max का value. So F max आप कितना निकालोगे? Mu into N. What is the normal reaction acting on this body? इस बॉडी पे अगर आप नॉर्मल रिएक्शन की बात करो कितना लगेगा नीचे mg that is your g and upward direction में normal reaction. So n has to be equal to 10. Mu is how much? 0.5. So 0.5 into 10, yani ki F max will be 5 Newton. Now let's move to the question. So, and also it is given that this string length can vary from 1 meter to 1.5 meter. You need to read the question carefully. ये नहीं कह रहा है कि this block is moving towards the uh, axis of rotation and gradually this segment length is decreasing. No, this block is at rest, right? A is at rest. So a string length connecting A and joining this axis of rotation is constant, right? Done. So what is the meaning of this? R is varying from 1 meter to 1.5 meter means you are experimenting this particular thing with different length of a string. So maybe first time you have used 1.2 meter of a string, another time you are using 1.3 meter of a string. Done it. So it has to do with that. With this data, what estimate can be made about the angular speed of the disk? Angular speed of disk का क्या estimate निकाल सकते हो? You may be thinking क्या करूँ? कैसे करूँ कैसे कहाँ से स्टार्ट करूँ तो you're right to think this but let me make it easier for you. I will make you understand this more better क्योंकि हमें ओमेगा का क्या निकालना है ओमेगा की बात करनी है what can be its omega. So let me tell you in some cases omega will we can get omega max and in one another case we can get omega minimum. So what are these cases ये है क्या? Let's understand it. Suppose करो I have taken one platform. I have taken one body that is marked here with red. Suppose कर लो ये एक turn table है झूला देखा होगा आपने मेले में turn table used to be like this and initially turn table is at rest let's say and you are sitting here in place of this red block you are sitting there. So I just want to ask you one thing. The moment this turntable angular velocity will be turned on, what you will feel? Will you feel you are getting thrown outward, or will you feel you are getting thrown inward? I just want you to pause the video here and think for some minutes. So आपको क्या लगता है, आपको कैसा feel होगा? So my answer will be, you will feel like you're getting thrown outward. How I can explain this? So uh, for this I have taken one assumption here, that this surface is smooth. Okay, so in that case I'm saying you will feel like you're getting thrown outward even if there is a friction. For a moment, for a very small time, you feel like you are getting thrown outward in that case also. So let's read this question carefully. अब इस चीज को explain करती हूँ मैं, why I'm feeling like this, why I'm answering you will feel like getting thrown outward. So suppose कर लो मैं यहाँ पे खड़ी हूँ and I want to observe your motion. So I will say that I'm standing on a non-inertial frame, right? Because the moment this turntable is switched on, every point of this disk is rotating with angular velocity omega, correct? सारे point omega से rotate कर रहे. If I take any point just below, I mean, if I take any point on the surface just below you, then that point is also having centripetal acceleration omega squared r. So basically, I am trying to observe you from a non-inertial frame, and whenever we work from non-inertial frame, and in from that frame, if we have to write free body diagram, हम कैसे लिखते हैं? First, we apply pseudo force. Pseudo force क्या होता है? Mass of that body getting absorbed into acceleration of that frame, and we apply this pseudo force opposite to the direction of acceleration. So here pseudo force will act in this sense, m omega squared r. So you are sitting on a platform. This surface is smooth. Okay? So if this surface is smooth, you will see that there is only one force acting on this block, and that is outward. And so you will feel like you are getting thrown outward. But what if there is friction? So in that case, as m omega square r will act, the moment omega will not remain zero, friction will start operating. So for some fraction of second, you will feel like you are getting thrown outward, but very soon you will get controlled by friction acting in this direction. So that will try to balance you. And in case F can be equal to m omega square r, you will be sitting at rest on that moving turntable. Okay? So this is the case. So there is a chance that in this case that you can slip outward, right? There is also a chance that you can slip inward. I can say, kaise? Dekho, that can happen if there is some external force acting on the block in inward sense, and that can happen in our question क्योंकि हमारे question में block A is connected with a string, so it has T tension acting always towards the center, right? So this is T. अब suppose करो मैंने सपोज अर्थ से ही इक्वेशन लिखते, कोई चाप नहीं है, कहीं से भी लिख लो. सो टी ऐसा डन है. लेट्स से आई एम सेइंग दैट this block has tendency to slip outward. So I mean it is moving with omega. Done hai? Let me explain it in you more detail. If it is rotating with omega, tension T is acting. If T is equal to m omega square r, if tension is able to provide centripetal force, no friction will operate. फ्रिक्शन कोएफिशिएंट है तो भी ऑपरेट नहीं करेगा बिकॉज रिक्वायरमेंट नहीं है, राइट? फ्रिक्शन तभी आता है जब रिक्वायरमेंट होता है. यू मस्ट हैव स्टडीड दिस इन बैंक रोड. सो यहाँ पे भी अगर टेंशन एम ओमेगा स्क्वायर आर के बराबर है तो उसको रिक्वायरमेंट नहीं है, राइट? So friction की requirement नहीं है, friction will not come. But let's say this omega is increasing. So if you are increasing omega, you need more inward force in this direction to balance the thing. So if you are increasing omega, this block will have then tendency to slip outward. Done hai? And in that case, friction will act inward. ठीक है? So when block will have tendency to slip outward, friction will act inward. ऐसे भी आपको पता है, block ऐसे inclined plane पे पढ़ते हो, अगर ये block नीचे की तरफ slip करने की tendency है, friction will act up. So if this block has tendency to slip outward, जो कि इसके पास हो सकता है, depending on the value of omega, then friction will act inward. First case. Second case ये भी हो सकता है, it may slip out, inward. और ये कब हो सकता है? Let's say omega value is little. omega is not that strong, and tension is becoming greater than m omega square r. So this is providing centripetal force, but it has more than that amount of force. Okay, so it will try to pull this block towards the axis of rotation. So it will have tendency in that case to slip inward. तो फ्रिक्शन जल्दी से एक्शन में आ जाएगा क्योंकि यहाँ पे फ्रिक्शन है, and it will get applied in the outward sense, and so it will stop this slipping. If you have to keep this block A on the rest, then friction will act to stop it slipping outward or stop it slip it inward, right? So you may have understood these two things, that in this question, this block may have a tendency to slip outward and slip inward. And in both cases, we will get different omega values. Let's now talk about first case. Suppose कर लो यहाँ पे इसका tendency है slipping outward का, and in this diagram I will write equation of slipping inward. Let's write equation from the ground. So when it has tendency to slip outward, friction will act inward. Simple. ठीक है? And what more force will act inward? Tension was there. Tension T. Done है? So T plus F in this case will be equal to how much? M omega square R. And you can see, acha theek hai, abhi nahi, let's write for this inward thing also. So if it has tendency to slip inward, friction will act in the outward sense. Tension always acts away from the body, so towards the center. And in this case, if you write equation, you will say that T minus F equal to M omega square R. अब दोनों में ओमेगा सेम नहीं हो सकता. देखो यहाँ पे ओमेगा T plus F है, M omega square R, और यहाँ पे M omega square क्या है? T minus F है. So here omega has tendency to be max, and here omega has tendency to be minimum. So we will be defining omega max and omega minimum both. Omega max we will be getting in which case? When block has tendency to slip outward. कहने का मतलब ये है कि when you are turning on the switch, when you started increasing omega from 0 to some value, initially when it is increasing, omega is lesser. In that case, it has tendency to slip inward, and when it is increasing and reaching some higher value, now it will have tendency to slip outward. So always we need to have a velocity of this turntable, uh, omega greater than omega minimum, so that it cannot slip inward, and omega less than omega max, so that it cannot slip outward. So we need to put omega in this cap. In which cap? Omega minimum less than omega, and this is omega max. Omega greater than omega minimum and less than omega max. Now let's calculate this value then. So अगर आप m ओमेगा मैक्स को निकाल रहे हो स्क्वायर आर को, तो आप क्या लिखोगे? टी प्लस एफ लिखोगे. टेंशन कितना था हमें याद है 20, फ्रिक्शन कितना था 5, और मास कितना है बताओ? मास का वैल्यू 1 था. रेडियस क्या दिया हुआ था क्वेश्चन में? इज इट गिवन? नो, इट इज वेरिएबल अगेन, राइट? सो आर को आर ही रहने दो आप अभी. सो ओमेगा मैक्स का स्क्वायर कितना जा रहा है बताओ? 25/r, राइट? और ओमेगा मिनिमम का स्क्वायर अगर आप निकालोगे तो क्या करोगे? t minus f by r, sorry, this is also square, so this will be how much? 20 minus 5 by r, so this is 15 by r. अगेन देखो थोड़ा सा ज्यादा करना है इस क्वेश्चन में. अब देखो ओमेगा मैक्स का स्क्वायर का भी वैल्यू आर का फंक्शन हो रहा है, ठीक है? सो ओमेगा मैक्स के लिए भी तुम्हें स्क्वायर के लिए दो वैल्यू मिलेगा. एक तो होगा आर का वैल्यू कहाँ से कहाँ तक वेरी कर रहा है. आर इज वेरिंग फ्रॉम 1 to 1.5, so one value will be this, and another value will be how much? It will be 15 by, देखो मैं बोलती बहुत जल्दी हूँ. So another value is 1.5. So this is 1.5. ठीक है? एंड सेकंड क्या होगा? यहाँ पे आप ओमेगा मिनिमम में चले जाओ. एक वैल्यू तुम्हारा क्या होने वाला है? दैट विल बी 15 बाई, ओके, मैक्स निकाला ना मैंने. मैक्स के लिए तो मुझे 25 लिखना था, तो मैंने 15 लिख दिया. Okay, so I have done here mistake. Let's replace this 25. Not such a big mistake. I've just misplaced the digits. So this omega minimum अगर आपको निकालना है तो क्या करोगे? 15 by 1, and next case में omega minimum क्या होगा? 15 by how much? 1.5. So I mean which value to consider? कौन से value को आप consider करने वाले हो? देखो, ओमेगा मैक्स के केस में हमें क्या क्या आने वाला है, एक ओमेगा मैक्स हमारा आया है 25 और दूसरे को अगर आप सॉल्व करोगे आएगा 16.67। सो दिस आर द टू वैल्यूज ऑफ ओमेगा मैक्स। सो अगर आर का लेंथ आपने 1 मीटर रखा तो ओमेगा मैक्स कैन बी 25, और आर का वैल्यू अगर आपने 1.5 रखा तो ओमेगा मैक्स कैन बी 16.67। एंड आर कैन वेरी फ्रॉम 1 to 1.5, एनीथिंग इट कैन बी। सो हमें सेफ साइड लेना होगा, यानी कि ओमेगा मैक्स का ये वैल्यू हमें कंसीडर करना होगा, क्योंकि इस लेंथ के लिए अगर ओमेगा मैक्स 25 होता है तो बॉडी स्लिप कर जाएगा, डन, दैट विल slip out of the platform, right? So we need to consider safest value, this will be the value. Similarly minimum के लिए आप देख लो, minimum के लिए हमें वैल्यू क्या क्या मिलने वाला है, you just check here, this is 15 and this is your 10। सो हमारे पास अगेन दो वैल्यूज हैं, एक है तुम्हारा 15 और दूसरा तुम्हारा क्या है 10। अब कौन सा लेंगे बताओ, ओमेगा मिनिमम, दिस इज फॉर विच लेंथ, दिस इज फॉर 1 मीटर लेंथ एंड दिस इज फॉर 1.5 मीटर लेंथ। तो देखो, जब स्ट्रिंग का लेंथ 1 मीटर होगा तो मिनिमम वैल्यू ये हो सकता है, अगर इससे छोटा हुआ तो दैट विल स्लिप इनवर्ड, डन है। यानी कि इफ ओमेगा मिनिमम कैन बी 10 फॉर 1.5 मीटर, लेकिन 1 मीटर के लिए तो 11 भी हुआ तो स्लिप इनवर्ट हो जाएगा, 12 भी हुआ तो स्लिप इनवर्ट होगा, यानी कि ओमेगा मिनिमम कैन बी दिस 15। सो ओमेगा का रेंज आप क्या लिखोगे, 16.67 एंड दिस विल बी लेस देन, सॉरी 15, yes, it should be this, done it? So this will be the answer. I know it was too much a discussion, but it was a very good question in terms of understanding the concepts. Okay? I hope you've understood it, but even if you feel like somewhere you couldn't understand certain points, you can always let me know in the comment section. Thank you. Keep on solving more number of questions. Bye.